Hello my dear students. I can see so many of you are a little bit confused about like today's live session, how it's going to happen, and so many of you already have finished about your life, about your examination and all. So yes, at first be chill. Okay, I know you just have completed your preparatory examination, so just chill a little bit. Basically, there are so many schools out there, right? So they have different schedules, right? Few of them they are having tomorrow, few of them they are having 21st. So depending upon these, we have planned the lectures. Anyway, if you are not if you are not ready for the second PUC chemistry examination, maybe it's tomorrow or on 21st, this video is for you only. Okay, so yes, here again we came up with the most important question that can help you to get a better marks in your second preparatory examination. So without further delay we can proceed. So yes, so you can be assured that that's gonna be kind of, you know, MCQ based and numerical problems few we will solve, and definitely the list of questions which are going to be most important, that also I'm going to share with you, and you can be assured that yes, we can get the common question out of it. Okay, so yes, without further delay we can start. So here if you are just doing simultaneously your KCET preparation, then our Diksha Karnataka channel came up with the most awaited ABHYAS KCET test series. So without further delay, please enroll yourself to get yourself top 1000 rank. So yes, here comes a few MCQs. So we will at first start with few MCQ questions, and then we will proceed with some short question, 2 to 5 marker, that we will also do, and few numericals I have targeted, expected that those type of numericals only we will get. Okay, and for those people, I just wanted to tell you people, my dear, see, question comes, we being a faculty, we can research a lot and we can give the question which actually resembles to your paper, right, that are quite similar. It's not that same question, maybe 20 question you have to answer and 20 question I'm giving to you. It's not like that. Okay, we can give you some resemblance out of it. Okay, means if I give you this much, you can get this much common. Okay, so you have to study this much at first to get this much common. Understand this psychology at first. Okay, so let's proceed further. Let's proceed further. So here you can see the mass percentage, that is W by W of glucose in water, it's 10%. What does it mean? So here you can see 10 gram of glucose dissolved in 100 gram of water, 10 gram of glucose dissolved in 90 ml of water, 10 gram of glucose dissolved in 100 ml of water, and 10 gram of glucose dissolved in 90 gram of water. So that's gonna be the correct answer. So because why this happens, whenever it comes to the weight by weight, then 100 gram is the solution. 100 gram should be the weight of the solution, and 10 gram they are mentioning about the glucose. 10 gram they are mentioning about the glucose. So 10 gram if it is glucose, and 100 gram is the amount of the solution, entire solution. So 100 minus 10, it is going to be 90 gram of water out of it. Okay, so let's proceed further. No, it's not actually helpful that much for the NEET student as of now, because we are focusing on the second preparatory examination for the Karnataka board. So definitely the upcoming live session will come for the NEET students and JEE students as well. So let's proceed further. The reagent that is used for the Sandmeyer's reaction. So as you know, it's a very common thing, CO2, Cl2 and HCl. So I want you people to answer with me so that I can understand where you are actually standing, where your preparation is going on, how your preparation is going on right now, and you can also understand where your competitors are standing right now, right? So yeah, let's proceed. So this is a Sandmeyer's reaction. I just kept as a reference so that you can remember. Let's proceed further. Here you can see the main natural source of acetic acid, that is basically vinegar. right? Let's proceed. The reaction of aniline which produces Zwitter ion as a major product. So reaction of aniline. So Zwitter ion we see whenever it comes to this type of functionality with aniline. See, I am having NH2 along with that SO3H unit with this. Okay, so they basically exist in this type of equilibrium system. That is NH3 plus and SO3 minus. Okay, so you can see they can exist in Zwitter ionic configuration. So you can say sulfonation will help. That can give you this type of configuration and they will equilibrate in the Zwitter ionic form. Okay. Okay, again I can see some of the comments we had. Okay. Ma'am, today we had chemistry preparatory 2 and I will get 65. Is it good? Yes, definitely, my dear. It's definitely going to be good. Congratulations to you. Exam itself got over. Again I'm getting the same comment. Okay, so basically again I'm just once again I'm repeating the same thing, my dear. In different cases, in different colleges, they have different schedule. Maybe today you are done with your chemistry examination, maybe tomorrow some of the students are having, maybe 21st some of the students are having. So yes, chill my guys. At the end of the day, whoever is going to face the examination tomorrow, for them it's gonna be helpful. That's it. So yes, let's proceed further. So this is a thing that I have kept like for your reference. So if you give H2SO4 in aniline, it will be like it will form sulfonilic acid, and sulfonilic acid will be equilibrate in its Zwitter ionic form. Okay, that's a dipolar molecule. Next, you can see the ligand which forms more stable coordination complexes, that is C2O4 2 minus. C2O4 2 minus is the bidentate ligand, right? So whenever it comes to multiple denticity, more than one denticity, then it actually helps to form the more stable coordination compounds. Let's proceed. Next question, you can see the method used to separation of isomeric products obtained when phenol reacts with dilute HNO3 at low temperature. So basically whenever it comes to the reaction with the dilute HNO3, let me just show you with the reaction itself. It will give you ortho and para substitution, right? It will give you some ortho and para substitution. So here once you can see the para substitution, this para substitution is eligible for the intermolecular hydrogen bonding. What I said, intermolecular hydrogen bonding means one orthonitrophenol with another. So intermolecular hydrogen bonding, as a result of this, overall relative molecular weight will be higher and it will take more temperature to get boiled. Okay, so boiling point will be more. But for this particular case, if you see, it can face intramolecular hydrogen bonding, right? So for this case, the boiling point will be low. So definitely for this particular case, we can use steam distillation method, okay, because the boiling point difference will be comparative. Okay, let's proceed for the next one. Okay, I can see Sanjana is commenting, man, please give some tricks for remembering all the reaction, because whenever I get inside the exam hall, I get confused between the reactants and catalyst and all. Okay, my dear, because organic chemistry, if you take it as a very hectic thing, then definitely you are going to face this type of problems and all. But let me suggest you one thing. That one video I made, that is a rapid revision, 20-minute rapid revision on all the reaction chemistry, that you can see, that can help you out. And there I gave one table Okay, in that particular table, all the reaction, whatever the name reaction is there in the organic chemistry, they are listed in a proper way. And few cases in the 0 to hero session, I did the aldehyde ketones class, and the upcoming classes will be there on the organic chemistry as well. There I used so many brain maps that I made over there. Okay, so chemistry, whenever you will proceed with the things like brain maps and all in the organic chemistry, that's gonna help you in this thing. Okay, so let's proceed. In the following acid, vitamin, in the following acids, vitamin E is basically ascorbic acid. Okay, next let's proceed. The best reagent useful for separation of purification of aldehyde and ketones, that is going to be sodium hydrogen sulfide. Okay, so it's a very important zone for the question. Why? Because NaHSO3, that particular reagent, it only reacts with aldehyde, not with the ketone. Let's say I'm having a mixture of aldehyde and ketone both. Okay, so whenever I'm having the mixture of both, then ketone is not really good for the nucleophilic addition reaction because of the steric hindrance, right? Because see, both the R groups are there, and also the electronic effects are there in the ketone, so it's not that much susceptible for the nucleophilic addition. But whereas it comes to the matter of aldehyde, NaHSO3 means HSO3 minus is the nucleophile that will attack nicely in the carbonyl carbon, right? And as a result of this, it will make an water soluble compound, right? So later on what will happen, you can just separate it out, and you can just ketone will be separated and that particular compound will be separated. You can add some dilute alkali over there and you will get back your aldehyde or ketone. Okay, so let's proceed. The best reagent useful for the separation, okay, that thing we did. So this is the particular thing that I just explained, a very important zone for the examination. Please proceed. Okay, let's proceed further. First you can see statement 1, this is a statement based question, I guess you know, whoever you already have faced preparatory examination, so I guess you have faced this type of question over there in your 15 mark will be there MCQ, right? In that one statement based question is there. So you can see, if on mixing the two liquids the solution becomes hot, it implies that it shows negative deviation from Raoult's law. Okay, so once you are mixing two different solution, it's showing that it's like temperature is getting high and it implies a negative deviation of Raoult's law. So basically temperature is increasing, it means it's an exothermic reaction. It's an exothermic reaction, right? Exothermic reaction means del H of mixture is negative. Okay, whenever enthalpy of mixture is negative, then it is basically Raoult's law, right? It's basically Raoult's law, negative deviation. Okay, so statement 1 is definitely true. Statement 2, if you see, solution which shows negative deviations are accompanied by decrease in volume. So whenever it comes to the negative deviation, so definitely in that particular case also delta V mix is also negative. Okay, so definitely statement 1 and statement 2 both are going to be correct here. Okay, so let's proceed. cumin hydroperoxide on hydrolysis with dilute acid. So I guess you remember in the last time also in the session I told you that cumin to phenol synthesis is going to be very important. So cumin hydroperoxide on being hydrolyzed, it gives definitely phenol, along with that one byproduct, that is acetone. Okay, so let's proceed. Here you can see among the following cells, the cell used in the Apollo space program for providing electric power. So definitely that's going to be H2O2 fuel cell. Okay, I want you people to answer with me so that I can understand where you are actually preparing, in which level you are preparing right now, how much you are prepared for your upcoming examination, and you can see your competitors as well. Let's proceed further. Here you can see the mixture which shows positive deviation of Raoult's law. Okay, so let me just explain one by one what are the solution, N-hexane and N-heptane. So they are the members of basically homologous series. Okay, so whenever it comes to the matter of homologous series, then they are having a similar type of interaction. They are having a similar type of interaction. Okay, usually van der Waals interaction in between the surface area. Okay, so whenever the similar type of interaction means, let's say A and B, two different compound, right? One is N-hexane, another one is N-heptane. So the interaction between A and BB is equals to A and B, means once you are mixing N-hexane and N-heptane, they are also having the same type of interaction. So that is basically ideal solution, no deviation at all. Next you can see bromoethane and chloroethane. Again, they are of similar type of compound, so similar type of interaction after mixing as well. Next you can see ethanol and acetone. So ethanol and acetone, what basically happened, ethanol itself is having hydrogen bonding, very nice intermolecular hydrogen bonding. So AA interaction is very strong. Again, if you just look at the acetone, it's a polar molecule. So acetone-acetone interaction is also very strong. But whenever you are mixing ethanol and acetone, in between two ethanol molecule, the acetone is coming, right? In between two ethanol molecule, acetone is coming, right? As a result of this, it is disturbed, right? So AA interaction and BB interaction becomes greater than that of the AB interaction, right? So is that the case? So this is the case for the positive deviation. And if you just look for the chloroform and acetone, so chloroform and acetone after getting mixed, they form nice hydrogen bond, right? They form nice hydrogen bond. So AB interaction is more than that of AA and BB interaction. So answer is going to be C. I guess it's clear to you. Let's proceed. Here you can see a cell that converts energy of combustion of fuels like hydrogen and methane directly to electrical energy. So that is definitely is going to be fuel cell. Okay, let's proceed. A common name of the ethane dioic acid. Here you can see ethane dioic acid means definitely I'm having two carbon system because it's a eth system. Okay, and dioic acid means that's gonna be COOH and COOH. Okay, so it's going to be oxalic acid. Let's proceed further. Here you can see the main natural source. So I guess we did it. Again, it's repeated. Fine. Let's proceed. Okay, I can see so many of you are giving answers. It's nice to see your preparation is good. Let's proceed further. So here you can see it's a very important question. In your pre-board examination also this question came. So in your model paper also this MCQ was there. So we did it like in the model paper as well. So let's proceed further. Here you can see a student took 2 glasses of pure water from a filter. He cools glass A in a fridge and warms the other glass B on a stove. On comparing the solubility of oxygen of H2O in glass A and glass B. Okay, so this is actually the temperature, how the solubility is related to the temperature, right? So basically what happens if your temperature increases, If your temperature increases, what happens? Solubility decreases. So what you are doing actually, glass A, you are freezing means your temperature is lowered. Okay, so in the glass A, itself, temperature is low, means solubility is high, means here in the glass A itself you will be having more amount of O2. Okay, rather than that of B, because B you are heating, right? So here you can see in the glass A contains more oxygen than glass B. I guess it's clear to you. Let's proceed. From here one more question actually it comes. You can expect this question as well. In the previous year also this type of question came, like why aquatic animal they prefers the cold water rather than that of the hot water, right? So this type of question you can expect out of it. The same reason actually, cold water is having maximum or like more amount of dissolved oxygen that will be comfortable for those animal to survive, right? Let's proceed. Here you can see the common oxidation state shown by the element with atomic number 21. So atomic number 21 is scandium, right? So scandium electronic configuration, if you see, I'm just writing the valential electronic configuration, okay? So that is basically 3d1 4s2. Okay, so 3d1 4s2. So if you release this 3d1 4s2, it will get the noble gas like configuration, right? So most common oxidation state, thus it's +3. Okay, let's proceed. Here you can see for reaction 2NH3 platinum catalyst N2 plus 3H2, the rate is given. Okay, we have to find the rate. So here very important thing, this particular case, please remember this. Sometimes students gets diverted out of this type of question and they make it the answer correct as C. Okay, because here comes the stoichiometry 2, right? So just let me tell you, my dear, for this type of reaction, whenever they are mentioning that platinum is there as a catalyst, means any metal surface, decomposition of the gas is going on. Decomposition of any gas, maybe here the example is given with respect to ammonia, decomposition of ammonia. Maybe later on you will face with respect to HI, right? In those cases also sometimes they give the reaction on the gold surface. Okay, so if metal surface is given as a catalyst, then it's a zero order reaction and it's an experimental fact. Okay, it's an zero order reaction, means NH3 power 0 means 1. Okay, otherwise if it was not mentioned that it is on not on any kind of metal surface, then it's a second order reaction. Okay, so by default it says that it's a zero order reaction, it's an experimental fact. Okay, let's proceed further. Sorry. Sorry, just a minute. Okay, so here you can see the next question. Here you can see when an alkene reacts with a component X in CCl4, reddish brown color of component X disappears to yield vicinal dihalide. Component X. Okay, so basically what happens? It's a test for the unsaturation. Okay, so here you can see an alkene, whenever you are having one alkene, so alkene in presence of Br2 and CCl4, it forms this type of vicinal dibromide type of compound. Okay, vicinal dibromide type of compound. So as you can see, as the double bond is removed, Okay, so that's the reason the brown color, wait, just a minute, the reddish brown color of the component X disappears, means all the bromine reacted with this particular thing and it formed that vicinal dibromide type of compound, right? Vicinal dibromide type of compound. So all the bromine reacted, that's why the reddish brown color will go off, right? So as a result of this, you can say Br2 is the correct answer. Okay, I guess it's clear. Let's proceed. Okay, here you can see this type of one matching type of question you can get. Let's proceed further. Match the following transition metal compounds with their catalytic activity in corresponding process. Okay, the first one, TiCl4 and AlCH3 whole thrice. This is basically the Ziegler-Natta catalyst. Okay, this is basically the Ziegler-Natta catalyst, and it is used for the manufacture. Sorry, it's used for the manufacture of polythene. Okay, so it's going to be C. Okay, now next you can see PDCl2. PDCl2 is basically used for the Wakers process. Okay, now if you just look for the nickel is basically used for the hydrogenation of fat, that is D, and V2O5 is basically used for the contact process, that is B. Okay, so let's check the answers. B, D, A, C. Okay, I guess option B is the correct one. Option A and B, they are having similar type. Fine, anyone can be the correct one. I guess it's okay. Let's proceed. Here you can see which of the following is homoleptic complex. Okay, homoleptic complex in the sense whenever inside the coordination sphere you are having same type of ligand. You are having same type of ligand. Okay, inside the coordination sphere itself. Okay, so first one you can see here I am having two type of ligands, so it is heteroleptic. Here you can see here also you are having two type of ligands. Okay, here you can see here also you are having two type. Here in the coordination sphere itself you are having only ammonia, so that's gonna be the correct one. Let's proceed further. Here you can see the correct name of the reaction. So definitely I don't have to tell, it's Finkelstein reaction. You know it very well. Next, the chemical formula of the Hindenburg's reagent. So Hindenburg reagent is one of the most important concept that can come in your examination. So don't skip that. Okay, I know a few people you plan to skip the amines chapter, but trust me my dear, amines is a very simple innocent chapter. Very few selective question comes out of it. Okay, so like if you are intelligent enough, please don't skip amines. Hindenburg reagent is one of the most obvious question that comes from the amines chapter. Along with that, whatever the most important question, that also I will tell you after the MCQ. Okay, so basically it looks something like that. Benzyl sulfonyl chloride. Okay, so somewhere I saw one question, this same Hindenburg reagent, right? So they are giving the Hindenburg reagents are, then they gave the name. So whenever they are giving the name, the Lucas reagent, ZnCl2HCl, like that, this type of options were there. So two options were there. One is benzene sulfonyl chloride, another one was benzene sulfuryl chloride. Okay, so here are something, these are something that can be very much confusing to you, that sulfuryl chloride or sulfonyl chloride. Okay, this is sulfonyl chloride, so be careful about it. Okay, so let's proceed with this. Doctor advised a 50-year-old woman enough exposure to sunlight and addition of fish and egg yolk to her diet. Name the vitamin deficiency for the possible disease. Like diagnosed by the doctor. So basically whenever they are saying that you need to to be exposed in the sunlight and you need some this type of food, then definitely there are some vitamin D deficiency, right? Because you know in presence of sunlight vitamin D can get synthesized. Okay, let's proceed. Let's proceed. Here you can see salicylaldehyde can be prepared from which of the following reactants? So these are the reactants. I guess you know the name reaction from the phenol, chloroform and the NaOH you can get. Okay, so let's proceed. Let's proceed. The major product formed in the following reaction. So basically alcoholic KOH. So here comes a very beautiful things out there. Alcoholic KOH and aqueous KOH. So whenever it comes aqueous KOH, then it will be simple bromine will be replaced with OH. But whenever it will be given as alcoholic KOH, it will undergo beta elimination reaction. Okay, so now let me show you, my dear. Sorry. Okay, so now whenever the elimination will take place, it can happen in two different ways. Let me show you two different ways at first. The first, you can see this hydrogen will jump here, this bromine will go off. CH3, here CH, double bond, CH, here CH3. Another way it can be done like this. If this hydrogen jumps here and this bromine goes off, the double bond can come here. CH3, CH2, CH, double bond, CH2, like this. Okay, so you can get two things out of it. So now the thing is, which is going to be the actual thing, actual product. So for this particular case, here Saytzev law, Saytzev rule will be applicable. So whenever it comes to the Saytzev rule, more substituted alkene will be the stable product. So if you just look at this particular alkene, it has two methyl substitution, but if you just look for this, it is only having one ethyl group substitution. So this particular is going to be the most stable one out of it. So the answer is going to be 2-butene, right? Answer is going to be 2-butene. I guess it's clear to you. Let's proceed. Here you can see one more statement type of question. In benzylic alcohols, let's at first draw it. Benzylic means benzene with one carbon with one OH. Okay, so this is attached to a sp3 carbon atom next to an aromatic ring. So definitely that's gonna be true. This particular carbon is going to be sp3 hybridized. Okay, let's proceed. Next statement. In vinylic alcohols, the OH group is bonded to a carbon atom, carbon-carbon double atom. Okay, so whenever it comes to the vinylic unit means carbon-carbon double bond. Directly to this carbon, I am having one OH, right? I am having one OH. So that particular carbon is going to be sp2, and yes, this OH is directly connected to the carbon, that is a part of the double bond. So both the statements are going to be correct. So option A is the correct option. Let's proceed here. Okay, again one match the following type of question. Phosphodiester linkage, glycosidic linkage, peptide linkage. Okay, chalo. So first one, if you just look at that, phosphodiester linkage that we see in nucleotides, right? Next, if you just look for the glycosidic linkage, then we can see it in the monosaccharides. Then if you just look for the peptide linkage, it's for the amino acid, that is option A. Okay, so your answer is going to be B, C, A, option D. I guess it's correct. I can see someone is giving correct answer and also responding. It's very good. Preparation is nice. Yes, let's proceed. Here you can see unit. It's one of the most important thing in chemistry. Okay, so you can't even ignore it, and if you ignore it, your full effort is going to be in the water. So don't ignore them in electrochemistry chapter majorly. Okay, so first you can see lambda m means molar conductivity. So molar conductivity unit, I'm not going to derive this, I'm just simply telling you the unit here. Okay, so in case you need the complete clarification of this type of things, means how the units are derived and all, then for those cases 0 to hero sessions are there. Then you can, next day I'm going to take the electrochemistry session in the long lecture video. So yes, please don't forget to watch that in the next day 0 to hero chemistry session. Yes, so for this case let me just write down the unit for you. So that's gonna be Simon centimeter square mole inverse. Next, E cell. E cell is going to be simple volt. For kappa it's going to be Simon centimeter inverse. Next, G star is called cell constant, it is L by A. So that's going to be centimeter inverse. Okay, let me just match them a little. I guess this question came in your preparatory examination, if I'm not wrong. Kappa is basically A, right? And this is G star is going to be B. 1C, 2D, 3A and 4B. Yes, option B is going to be the correct one. I guess it's clear to you. Let's proceed. Yes, hydration of acetylene, that is ethine with H2SO4 and HgSO4. So this is basically the oxymercuration, demercuration. Again, this particular thing it's a kind of preparation of aldehyde ketones, it comes. Okay, we did a complete full lectures on the aldehyde ketone chapter. If you are not having your proper concept clear in oxymercuration, demercuration chapter, please go and watch that video. Okay, so here you can see acetylene, means if I just draw the ethine like this, and if I give the reagent H2SO4 and HgSO4, I'm just writing OMDM. OMDM means oxymercuration, demercuration. This is the reagent out there. Okay, now it will give you something like this. Okay, it will give you something like this. Now this particular thing, it's a enol, right? So enol will be converted to its most stable keto form through ketoenol tautomerism, right? So they will be in equilibrium and they can form this thing. Okay, so you can get acetaldehyde out of it. Okay, I guess it's clear. Let's proceed. Here you can see a binary solution has two components A and B. The mole fraction of the component A is the 0.5. Then the number of moles in component A and B. So mole fraction of someone if I am having two component A and B and the mole fraction of A and B, if I add them, that's going to be 1, right? If someone is 0.5, then if I just find it out for the mole fraction of B, that's going to be also 0.5. So XB is also going to be 0.5. So if the mole fraction is similar, so definitely number of moles can be also similar, right? So I guess it's clear. Let's proceed. Here you can see the reagent which does not react with both acetone and benzaldehyde. So acetone, if you just look at, it's a ketone, right? And benzaldehyde, it's an aldehydic system. So let me just tell you, Felling's reagent is going to be the answer because Felling's reagent is a very mild oxidizing agent out there. It cannot react with the acetone, it cannot react with the ketone. Okay, it will react with the benzaldehyde itself. Let's proceed. Okay, potassium permanganate is a powerful oxidant. Yeah, definitely true. Next one, you can see KMnO4 oxidizes I- to IO3- in acidic solution. Okay, so here comes a very important portion. Why? Because whenever it comes to I- to IO3-, it only happens in alkaline media, right? But in acidic media, I- will be oxidized to I2. okay, not in IO3 minus. These conversion takes place in alkaline media. Okay, so statement 1 is true, statement 2 is incorrect. Wait, where I did. Statement 1 is correct, statement 2 is not correct. So option D. I guess it's okay. Let's proceed. MnCN whole 6 3 minus and FeF6 3 minus are inner orbital and outer orbital complexes. Okay, let me just explain a little bit what are inner orbital and outer orbital complex. So basically what happens, it completely depends upon the ligand that actually takes part in the hybridization. I mean, not in hybridization, basically that influences the hybridization. Okay, so if you just look for the ligand out there, one is cyanide and another one is F. So cyanide is a strong field ligand, right? So whenever it comes to the matter of a strong field ligand, it actually insists the electrons in the d orbitals to force paired, okay, against the Hund's rule. Okay, as a result of this, inner d orbital means n-1th d orbital gets vacant and hybridization takes place out there itself. Okay, so from there itself I can tell that Cn, as it will force pair the electrons of the manganese, so inner d orbital will be vacant and it will form the inner orbital complex. Okay, and for FeF6 it's not a strong field ligand, it's not a strong field ligand, so normal pairing up of electron is there, and outer orbit means 4d orbital of iron will take part. So outer orbit will take part in the hybridization process. So first one is inner, second one is outer. Option A is going to be the correct one. Let's proceed. Triiodomethane was used earlier as an antiseptic. The antiseptic properties are due to the liberation of iodine. Option B is going to be the correct one. Let's proceed, let's proceed, let's proceed. I can see someone is very active in the comment section. Yes, very good. Your preparation is really well, it's impressive. I want the rest of the people to respond as well, so that I can understand where you are actually belonging, in which level your preparation is right now. Okay, so yeah, let's proceed further. Here you can see 10 ml of liquid A and 20 ml of liquid B are mixed at 25 degrees Celsius. So the volume of the solution is 30.1 ml. Okay, so now here you can see here they did the trick. How? So whenever you are mixing 20 plus how much? 10. 20 plus 10, you should get 30 ml, right? But they are saying you are actually getting 30.1 ml. Means delta V, means change in volume of the mixture, is actually greater than 0. 0.1, it's greater than 0. When does it possible? It's possible whenever you are having the positive deviation of Raoult's law, isn't it? It's more than 0. So it will tell you it's basically nothing but the positive deviation of Raoult's law. Okay, and positive deviation of Raoult's law. Okay, so positive deviation of Raoult's law also indicates that a delta H mix value, means enthalpy of mixture, also should be greater than 0, means endothermic. So let's check for the answer. It's option C. I guess it's correct. It's okay for you. Let's proceed. Here you can see acetylation of salicylic acid produces a compound which has anti-inflammatory and antipyretic property. So yeah, that's going to be aspirin. So aspirin is basically something that you get out of the acetylation of the salicylic acid. So there is a brilliant story behind the discovery of aspirin. So yes, definitely in that class, whenever we will do this aspirin and all synthesis in the phenol ether session, okay, in that case I will tell you the story in the 0 to hero session. Okay, so how these things happened and all, you will feel it literally very much outstanding. Okay, so let's proceed. Here you can see a question, 2a plus 3b plus half c gives product. The correct rate of the reaction. Okay, correct rate of the reaction. So first you can see, at first you can just write down the rate of the differential rate equation, then you can just rearrange them in accordance to the option. Okay, so here you can see, first we can write so here you can see already half is there, so this 2 will go up and we can write dc of dt. I'm not writing the product as it is also not mentioned in this particular options as well. So if I just rearrange a little, if I just multiply this 2 with the other things, so minus dA of dt is going to be minus 2 by 3 dB by dt is basically equals to minus 4 of dC by dt. Okay, so yeah, A is going to be the correct option. I guess it's clear. It's clear. Let's proceed. Yes, definitely aspirin can be produced using the phenol, from phenol to salicylic acid, from salicylic acid to aspirin. We can go as of like whatever the level of JEE Mains and NEET, up to that level we study like that. But if you just know the actual story of the aspirin, it actually started from the salicylic acid itself. Okay, so salicylic acid was the first starting element from where the aspirin was first time discovered, not phenol. Later on it can be converted from phenol to aspirin, like that. Let's proceed further. Okay, so here we ended up with our this thing, all the MCQs, whatever possible, trust me my guys, you can get common out of it. So let's proceed further. Here you can see little bit most important question, short question I can tell you from where you can really get common question in your upcoming examination. So yes, first we will proceed with the solution chapter. So these are the list of questions. So among them I can tell you, first Henry's law, mathematical form of Henry's law. It's going to be very important for you because it is also there in the model paper as well. Okay, application of Henry's law, 3 applications are there. You can expect 2 marker question or 3 marker question out of it. Difference between ideal and non-ideal solution, and also you can get the question on, also you can get the question difference between positive deviation and a negative deviation, that also you can expect. Okay, next you can see water azeotropes or azeotropic mixture, give one example. And one important question here, why the components, whenever it comes to the non-ideal binary solution, they cannot be completely separated using the fractional distillation, because they form azeotropic mixture. That's why they cannot be separated, because they boils at the same temperature, right? So this question is important, and these are some application based question for the from the osmosis itself. Just go through them once. Like you can get the blood cells collapse when it is suspended in the saline water. Why? Because the osmosis phenomenon, I guess you can understand this. Next, what is a reverse osmosis? Application desalination, I guess you can proceed with, and reverse osmosis definition, you can proceed with that. Next you can see, name the concentration term. It is a question that is taken from the model paper, and it feels like it's a very important question. You can get the question. Okay, so please don't avoid it. It's basically weight by volume percentage. Okay, so let's proceed. Here you can see one of the most common type of numerical problem from the chapter solution that you can get. This is related to the elevation of boiling point. Okay, just simply apply the formula. The formula, I guess you know, I don't have to tell you, that delta TB equals to KB into M. So if you apply this formula, that's gonna be shorted. Okay, now let me just tell you, my dear, whenever it comes to the numerical problem, so whenever you are discussing the overall chapter, overall chapter means overall syllabus throughout the thing, then from the solution itself they becomes very much specific, right? From all the zone they don't give the numerical, right? So Raoult's law, you can really expect very less number of numerical, but still you can get one graphical numerical, graphical based you got last time, I guess, graph based numerical. That was also quite easier. But for this particular case, I suggest you to proceed with the colligative properties, all the formula of the colligative properties. From there you can expect the numerical problems. That's most important. Okay, so I guess it's clear to you what are the question zone, what do you have to study. Definitely you are going to get the PDF after this session. So yes, let's proceed. Electrochemistry, one of the chapter in which student gets maximum scared. So don't get scared. Most important questions that can include the salt bridge. What are the role of salt bridge? What are inert electrodes? Example, limiting molar conductivity. Define limiting molar conductivity in the pre-board also you got actually that type of question. And cold rush law, direct they can ask, or they can give the numerical related to the cold rush law. Okay, application based question of the cold rush law, that is only the numerical. Okay, and next you can see, name the type of batteries or the commercial cells. These are the direct question, you know. Faraday's first law, second law, anyone they can ask. Okay, very common question. Usually they give first law. You can see so many years it is repeated, right? Next you can see, explain the methods used to prevent corrosion. Corrosion related question you can get even in the model paper. Those type of questions are there. Diagram based question was there on the basis of corrosion. Okay, so don't forget to study that. And the reactions of nickel cadmium battery, that is also going to be important because it is also from the model paper. So yeah, don't forget to go through them. Next you can see, here you can see one questions, and numerical based questions are there. The first one you can see, on the basis of Nernst equation you can simply answer this question, and this question it is lambda m0 and the value lambda 0 and all these values are given. It is from the cold rush law itself. So I am actually willing to proceed with one numerical problem so that you can understand the pattern of it. So I guess that's gonna be helpful for you. So let me just proceed with one numerical so that you can understand. Okay, so you can see here one question, calculate the electromotive force of the cell. Assume the cell reaction at 25 degrees Celsius with the reaction this, CO2 plus 2 Ag is this. Okay, E0 cell value is given. Okay, for these numerical, let me solve it for you. I guess this type of one question you will get. Okay, so let me just proceed with this numerical. Okay, so first just apply the simple Nernst equation because this is the major question zone from the electrochemistry chapter itself. Okay, so here you can see, okay, let me change the ink just a minute. E cell is basically equals to E0 cell minus 0.0592 divided by N log Cu2 plus divided by Ag plus square. Okay, because you can see product by reactant we write, right? So this is the Ag we will not take in the solid state because it is the concentration is taken as 1. So we can take Cu2 plus divided by Ag plus, the stoichiometry will go to the power, right? Okay, now let's put the concentration term. E0 cell value was something 2.97 minus 0.0592 divided by, it's a 2 electron exchange process, log I guess it was 0.250 divided by 1.0 whole square, I guess Okay, let me just proceed a little bit. 2.97 minus, if I do this calculation, 0.0296, yes, log, from here I can write as 0.25, right? So log 0.25, see, you people get the log table, but still if you want to simplify this type of calculation, you can do it like this. Log 25 divided by 100, right? Yes. So from here I can write it in this way, log 1 by 4, right? From here log 1 minus log 2 square, right? From here log 1 is 0, I guess you know. And from here log 2 value, you know, 0.30, I guess. 2 into 0.301, right? So if you proceed with this, I will get minus 0.602. Yes, so that we can write here 2.97 minus 0.296 into 0.602. Okay, so now if you do the overall calculation, it will come as, rest of the things I guess you can do, you can proceed with it. Yes, here one minus sign was there, so minus minus it will be plus, you will get 2.987 volt. Okay, that's going to be the answer. Please don't miss the unit at the end. So this type of problem you can get. So simple type of problem only you will get, don't worry about it. Okay, I guess it's clear to you. Let's proceed. So these type of log calculation, we will again come up with the tricks and hacks to calculate this type of things without calculator. So don't worry about it. As of now, as your board examination is coming, so definitely you can get your log table and you can use your calculators as well. Okay, so don't be worried so much about this type of calculation. So just before your JEE Mains or KCET examination, we will share the hacks and tricks to solve this type of thing. Okay, so let's proceed. A column containing 0.05 molar NaOH. Okay, this is also a numerical problem. Okay, let me see that. Has an area of cross section 0.785 centimeter square and length of 1 meter, shows a resistance 1.11 into 10 power 4 ohm. Calculate the molar conductivity of the solution. Okay, so this is from the conductance zone. Let me just solve one more. With this type of problem, you can see. So G star is basically equals to L by A. That are the things we know. So from here, if we just put the value, length is said by the question 1 meter. 1 meter means 100 centimeter, right? So 100 centimeter divided by 0.785 centimeter square. Just a minute, let me just do the calculation. So it will come as G star equals to, almost equals to 1.27.3885 centimeter inverse, right? So G star means it is the cell constant, right? Now what we can do using the G star, we can calculate the kappa. Okay, so kappa is basically conductivity. Kappa is G star by R, right? So from here, if I put the value of G star, that is 127. Okay, this is not 1.27, sorry. This is 127. So 127.3885 centimeter inverse divided by, what is the ohm value? 1.11 into 10 power 4 ohm. Just let me do the calculation. So you can get 0.01147 Simon centimeter inverse out of it. Okay, so this is your step number 1. this is your step 2. Okay, from here what you can do, step 3. Here I can do lambda m, that is basically kappa into 1000 divided by C, right? So here simply you can just put the value. So kappa value from there you can put 0.011476 Simon centimeter inverse into 1000 divided by concentration is given 0.05. Okay, 0.05 molar, right? So if you do the calculation, your answer should come as 229.52 Simon centimeter square per mole. Okay, if you just break down this molarity unit, then this centimeter and mole you will get. Okay, so I guess it's clear to you. First you calculate. See, sometimes we don't get what are the steps to be followed for this type of problems. So just write down what are the information given to you and where you have to come. They are asking for the molar conductivity. For molar conductivity I need kappa, right? For kappa I need G star and R, right? So let's calculate G star. Like that, back calculation sometimes works. Okay, so I guess it's clear to you. Let's proceed. Okay, so this is chemical kinetics. Some short question we will proceed. Here you can see difference between order and molecularity, very common question, 2-marker question you can get out of it. Next you can see a chemical reaction A plus B gives C plus D. The concentration of reactant A alone is increased by 2 times. Okay, this is a numerical type of question. 2-marker question only you can get this type of. Okay, so whenever they will say that A is increased by 2 times or B is halved with the time, like that, just normal random example I'm giving. So just at first make the equation. Okay, make the equation, then solve it for X and Y. Okay, I guess it will work. One this type of problem we will do, don't worry. What is pseudo first order reaction? I guess I don't have to tell this, as a very common question, and one example you can give in like inversion of cane sugars and all. Next, write the Arrhenius equation, very important, and whenever you are writing the equation, any equation, it's not only for the Arrhenius equation, then make sure that you are mentioning the abbreviation. Next you can see what are the main criteria for the effective collision according to the simple collision theory. So effective collision, I guess you know, orientation, energy barrier, so this thing you can mention. Okay, next derive the integrated. It's a very important question, my dear. First order and zero order reaction, anyone you can expect the entire derivation, either first order or zero order. Okay, not more than that. You can expect the entire derivation, so that can carry 3 mark. Okay, so please don't miss it. Next you can see for the reaction H2 plus I2 gives H2HI, draw the energy diagram showing the plot of potential energy versus the coordination, explain the role of activated complex in the reaction. So basically what happens, this is something, again I'm telling you, we will do it in detail in the 0 to hero session. This is just a question paper solve, and not question paper, just to give you the list of the questions. It's not for the explanation. So for the explanation, it's one of the model paper question. You can check the model paper as well for the detailed explanation. So if you start from a reactant, if you want to end up with a product, it proceeds through a energy barrier, right? And at the top of this energy barrier, here exists the transition state. In the transition state, the activated complex exists. Okay, so any reactant, when it comes to the product, it has to proceed through a activated complex state. Okay, that you have to explain with respect to this graph. Okay, next mention 3 factors that affect the rate of the chemical reaction. So you can write the temperature, Arrhenius equation a little bit you can write, concentration, so you know, catalyst you can target. Okay, I guess it's clear to you. You understood the zone of the question, I guess. Let's proceed. Here comes the, see, I have taken very few numerical, very selectively I have chosen, so that you understand that from which zone actually the numerical may come. Okay, first this particular thing is a first order integrated rate law that you have to do. Okay, this one type I will do. Let's do this one. Okay. Next you can see the first order rate constant for the decomposition, calculate, okay, this particular thing is for the Arrhenius equation. So for this chapter majorly we have two zone, one is rate, another one is Arrhenius equation. Majorly you can get the concept, I mean numerical problems out of these two zones. Okay, so let's solve for this one. This is the last question. A first order reaction has half-life 23. Okay, how much time will be needed for 30% completion of the reaction? Okay, let's do it. Okay, so T half. So 0.693 divided by K, right? This is the formula for the half-life. So from here I can calculate K, 0.693 divided by T half. So from here I can calculate K by 0.693 divided by 23. Let me just do it. It will come almost as 0.03013 minute inverse. Right, now put the value of this K into the first order integrated rate law. T equals to 2.303 divided by 0.0313 minute inverse log. How much completion? I guess 70 or something. 30% completion. Okay, so 30% completion means I can take A0 as 100 and 80 means if 30% is completed means 70% is still there. Right, I can just keep it like that. So now simple calculation actually. So I need calculator here. Yes, 76.4. Wait. Okay, here you will get 76.436 out of it. 436 minute. Here you can get, and here you will get 1.43. Yeah. Now if you calculate further, then wait just a minute. You can get 76.436 into 0.15488 minute. Okay. So if you further calculate this, then you will get it as 11.84 minute. That's it. That's your answer. Okay, I guess it's clear to you. Yeah, let's proceed. I have seen you people sometimes whenever teachers use calculator, you feel pride. Okay ma'am, you are also using calculator. No. So yes, we are not human calculator, my dear. Sometimes we also have to use it. Okay, anyway, you can see this is D and F block elements. So these are the question sets. You can see first is transition element, means water transition element given exam, and why zinc, cadmium, mercury are not included in the transition element. Why they are not transition element? That's very important because they are having field d orbital. Okay, next 3D transition metal exhibit +2 as most common oxidation state, except, okay, this is SC, okay, this is not SD, this is SC, typing mistake, sorry. So what is the reason behind it? Because it is having 4s2 outermost cell, so that gets eliminated most of the cases. Definitely copper, scandium exhibit +3 oxidation state usually. Okay, so there are variation, but in general that 4s2 electron they gets removed, that's why +2 oxidation state you can get. Next you can see, name the element of 3D series which shows maximum or highest oxidation state. Okay, so that particular thing also is done. It is basically the manganese. Okay, next name the transition element which does not exhibit variable oxidation state. Okay, here one thing I just wanted to convey here. For the manganese, you know, what happens, manganese exhibits maximum oxidation state, okay, up to +7. Okay, so for this particular case, and for this it's a different answer which does not exhibit, it is zinc basically, because it is having 4s2 only +2 oxidation state it shows. But I wanted to tell about manganese because it has +7 up to +7 oxidation state, and it only forms compound in that particular oxidation state with oxygen. Okay, it's a very important question zone, that's why I felt like I should convey this thing to you. So what basically happens here, so oxygen, it can form multiple bond, and manganese and oxygen bond is nicely covalent, okay, and the compound becomes entirely very much stable at +7 oxidation state. Okay, so I guess this particular thing also you will remember. Next, calculate the spin only magnetic moment. I guess you remember under root n into n plus 2, that is a formula of it. You can put the value of n out there. Okay, you can put the value of n out there, that is your unpaired electron, number of unpaired electron. Okay, next, zinc salt is colorless. This type of question like why Cu2 plus means copper sulfate 5 H2SO4, why these are blue in colored and all, this type of question you can accept, you can expect out of it. So Zn2 plus is colorless because there is no D to D transition. Whenever something will come related to color, please mention the point D to D transition. Means D orbital gets splitted in accordance to the crystal field theory, right? From T to G to Eg, there can be transition of electron. Okay, so that transition is not possible because it is having 3D10 configuration. Again, you can see Cu2 plus salts are colored. Okay, so I guess you understood. Explain the catalytic property of the transition metals. This is just because of having so many variation of the oxidation state. Okay, that's the reason it shows catalytic properties. Next, you can see what is a lanthanide contraction. Mention two consequences, as you know that gradual decrease in the radii because of the presence of D and F orbital pore shielding effect, that is the lanthanide contraction. I guess you know this. Any two consequences you can write out of it, zirconium hafnium chemical twin, right, and the basicity order, that also you can mention out of it. These are two must do question from the D and F block. Okay, so how the potassium dichromate is manufactured and potassium permanganate. Okay, must do question, very important. Again, can you please comment 3-1? Okay, comment is deleted, fine. How is potassium permanganate is manufactured? It is one of the most important thing, and along with that, one attached question you can expect out of it, that is if you what should I say, cheminophore is if it is heated. Okay, if cheminophore is heated in presence of oxygen, okay, then what you will get, what gas you will get out of it. Okay, if cheminophore is heated in presence of oxygen, then you will get K2MnO4 along with that oxygen gas. Okay, so this is a question you can get out of it. Let's proceed further. Here you can see coordination compound. Okay, so coordination compound, when it comes, so these are the lists of question, that is the water ambient ligands, water homoleptic complexes. Give examples. Homoleptic complexes, I already told, homoleptic and heteroleptic complexes, what are them. Okay, what are the ionization isomerism. Any one isomerism they can pick and they can ask you the question along with the example. Okay, geometrical isomerism is a very important thing, Ma3B3, any type of compound they can give you the question, they can ask you the question. Okay, next you can see, next indicate the type of isomerism exhibited by the following complexes. You can see these complexes, Ma2B2 type of complex, you can do the geometrical isomerism for them. Then you can see Ma3B3, for them also you can get. So from for this case, okay, I guess it's clear. That's much I wanted to tell. Next few question I wanted to tell here, crystal field splitting theory, that you can get a 3-marker question out of it. Hybridization, magnetic properties and geometry, for these 3 complexes you can do all the thing, hybridization, magnetic properties and the geometry, all the 3 are important out of it. Okay, next, how many squared pyramidal unit present in the decacarbonyl dimanganese 0, write its molecular and structural formula. So this is something also came from the model paper itself. In the model paper I did the detailed solution of it, you can just go and watch it. Let's proceed. Haloalkanes and haloarenes. Okay, wait. Okay, I can see again my preparatory 2 examination and all, it's been completed. Okay, very good. Let's proceed. Haloalkanes and haloarenes. Okay, so Finkelstein reaction, Schwarz reaction, very common type question comes, SN1 SN2 difference, racemic mixture, Woods-Fittig reaction, Fittig reaction. These are the very common thing. You can see so many years these questions are repeated. One more thing I just wanted to convey you people, that tomorrow again I will come to live, and that's gonna be a mega marathon session for you people for the second preparatory examination. Whoever is left over, whose exam is not yet completed, for them it will be a mega marathon session. There all the answers, all the question I will explain in well and detail. Okay, even will come up with the more numerical problems. Okay, let's problem. Here you can see SN1 reaction mechanism, super important, don't skip it, and SN2 as well. Okay, let's proceed. Alcohols and phenols, these are the question chart. Okay, Lucas reagent is very important. Coles reaction, Raymatt-Tiemann reaction, mechanism of dehydration of ethanol, everything, like whatever it's written here, just don't skip them. Very selectively I have chosen the question, so please don't cut from here. Okay, I guess it's clear. Let's proceed with the aldehyde ketones. So these are the question from the aldehyde ketones as well. So preparation of aldehyde from the esters, like using the diol H, that you can proceed with. Etard reaction, it's a direct question. Next reagent that is used for the etard reaction, that is a chromyl chloride. Okay, next Gattermann-Koch reaction, that is also is going to be super important for you. Next everything, and next day tomorrow itself everything I will do it in front of you actually, so that you can understand. Even let's say I have study for the examination, if you see that video, tomorrow's lecture, I guess your concept will be crystal clear and you can see it, and at least you can get, I can assure to get you 60 marks at least. Okay, so yeah, let's proceed. Aldehydes are more reactive than that of the ketone. What is the reason behind its steric effect and electronic effect? Mechanism of addition of HCN, very important. Next, this is the thing I discussed in the MCQ session as well, that aldehyde and ketones react with NaHSO3. Which one? Aldehyde reacts, okay, not ketone. Okay, how they react, that also I explained there in the MCQ session. Tomorrow's session again I will tell. Okay, what is a Clementian reduction? Give example. This is a direct question, and Wolff-Kishner reduction as well. Okay, next we will proceed with the amines. Very innocent chapter, my dear, don't skip it. Okay, so very few questions are there. Hoffman bromamide degradation, very important question. Next one you can see decreasing order. The basicity order of amines are different in the gaseous phase and in the aqueous phase. Please don't mess up. That are the target zone they give in the MCQ. So yes, don't mess up that. Okay, just give me a minute. Yeah, let's proceed. Here you can see Hinzelberg reagent. Yes, I give carbylamine. Carbylamine, direct question it comes. Hinzelberg reagent, how do you distinguish? That I already told you what is the reagent and how do you distinguish that. Tomorrow again I will tell, like whenever you are dealing with the 1 degree amine, it will give you the turbidity. Sorry, it will not react with alkali. Whenever it is a 2 degree alkaline, 2 degree amine, then it will not react with the alkali. And the last case, if you just see Hinzelberg reagent, will not react with the 3 degree amines. Okay, so those things we will discuss in the tomorrow session as well. Gabriel thalamide reaction is one of the most important, that entire mechanism you have to proceed with. We will do it tomorrow. Biomolecules. So today actually I'm giving you the set of question. My target zone was just to my target zone was for today's live is the solving the MCQ and a little bit just a touch up of the numerical problem, you can say. Okay, and just to show that yes, these many questions you can prepare for your examination. Okay, so here you can see tomorrow's live session actually I will not target that many MCQs. Majorly I will target on these questions and numerical problem. More numerical we will do. Okay, so here you can see reducing sugar and non-reducing sugar, both of them are important, and for those cases examples, and why they are reducing, why they are non-reducing, because they are having one aldehydic unit out of it. Okay, now you can see next question, the complete structural analysis of glucose itself is important. They can ask you the question like why you can say that glucose is having 6 carbon system, right? So because once you are hitting this thing with HI, it will give you N-hexane. Okay, that can give you the proof that glucose is having 6 carbon. Okay, so this type of question, it is having one carbonyl unit. Okay, hydroxylamine. So entire structural analysis of glucose is important. Then epimers and anomers definition, very important. Next, some very random question may comes from the hormones itself. They can ask you the name of few hormones and they can ask you what are the role of those hormones. Here I can give you the like example, the name of the hormone released rapidly to rise the blood glucose level, like it's the insulin, you know. Okay, so any question can give from the, they can give from the hormone, it's not really predicted. Okay, this is one of the most important because I have kept it from the model paper. Let's proceed. Here you can see peptide bond, what is peptide linkage, how it is formed, you know this thing, just because of the dehydration, like removal of 1 unit of water from the COOH and NH2 unit, right? That we will show in tomorrow's session. Proteins classification, I guess you can do fibrous and globular in accordance to one example. Also don't forget to give one characteristics also. Sometimes they ask the question with respect to the fibrous protein and globular protein, differentiate. Okay, so next, name the protein present in hair, that I know, I guess. Let's proceed. It's a most common question that I have seen. It's coming in the 1 marker from this biomolecule chapter, and you people also aware of it. It's an example of fibrous protein keratin. Okay, let's proceed. Howard structure of these glucose and maltose are most important. Okay, so you have to practice multiple times how you should process, how you should draw the structures. Tomorrow I will show you actually how you should draw the structures. Okay, so yeah, that's it for today. Don't forget to see tomorrow's live session from 4 p.m. itself. I will explain all the question and it will be a complete marathon of your entire syllabus of chemistry. And please share with your friends as much as possible. Don't forget to subscribe our channel if you have not done. And yes, finally, like it please, because yes, we are doing a lot for you people. Thank you so much. Thank you so much for watching. Thank you. One more thing, just wanted to convey, my dear. One more thing, someone was having some confusion related to the another one live session that's going to happen from 6 p.m. itself. So 6 p.m. So many of you are having English examination as well. So English live will be there as well, and Ankit sir's session, math session will also be there parallelly. Okay, so whatever it feels feasible for you, you may join over there, and Ankit sir sessions will be a little long, so you can join later as well. So it's up to you. Okay, so thank you so much. Thank you.